My name is Thomas Johnson, and I'm an associate professor in the School of Engineering. So, computer engineering is a field that is blending electrical engineering and computer science. And what excites me about a field like computer engineering that has these two components is that to me parallels how our technologies evolved as a convergence of both hardware and software. And I think almost every problem or a lot of engineering problems that we need to solve require both the hardware and the software sides of a design to provide the solution to the problem that we're looking for. So I think what excites me is being able to provide a solution or come up with a solution to a problem, and having knowledge on both the engineering and the computer science side to provide the technological solutions that would be required for that problem. What I'm teaching this term, I'm teaching a second-year course in computer engineering, which is very exciting. It's a survey course on the whole spectrum of computer engineering. I hope that creates a roadmap for subsequent courses that students will take. And then in my second term, I'll be teaching a course on microwave engineering. I think looking forward, if I were a student, most of our technological solutions are going to require both this amalgamation of hardware and software. And so a student who's studying in this program is going to interact with the electrical engineering faculty, and then they're going to interact with the computer science faculty coming from that science background. That exposes a student to really two different cultures, and you're bridging this together through some unique computer engineering courses to position yourself with knowledge that will allow you to work with both hardware and software to realize solutions to problems and applications. So I think that is super exciting, and I think there's a huge amount of opportunity by having background in both these areas. I would say to any student, this is a field that requires creativity. It requires a passion, and there is scientific and engineering principles, and you're essentially, I sometimes say it as an artist working with scientific principles to solve a problem and create things.
Hello, and welcome to UBC's Engineering Open House. My name is Thomas Johnson, and I'm the program chair for the computer engineering program that is delivered at the Okanagan campus. In this short video, I'd like to give you an overview of our program. Before I describe the program, let's briefly consider an example of computer engineering. I assume right now that you are streaming this video on possibly on a mobile device or a portable device, or maybe your computer. And that video, this video is stored at a data center, and that is something that I had recorded, that I'm recording right now, and that you can watch it at any time you'd like to. The internet also provides connectivity to many, many other resources that we use in our daily lives. And I've shown a few examples here. So just going through some of them, we got healthcare, banking, data centers, social media, virtual worlds, utilities and energy, food and agriculture, streaming platforms, manufacturing and automation, transportation, government, home, and shopping. And the design of the internet and the devices that connect to the internet and the software that we use to access the resources on the internet are all examples of computer engineering. So computer engineering is is really looking at both the hardware and the software that enables designing something like the internet and all the resources that connect to the internet. What skills do you require to work in the computer engineering field? Well, two very important pillars are electrical engineering, which gives you a foundation on the hardware side, and computer science, which is focused on software systems. And bridging these two is computer engineering that is working with both these fundamental areas. And our program is designed around core courses in electrical engineering, core courses in computer science, and specialized courses in computer engineering that use the knowledge bases of electrical and computer science. All of our programs here at the School of Engineering on the Okanagan campus begin with a common first-year program. And in that first-year program, you take courses on computing fundamentals, a first course in programming, data structures. There's courses on mathematical concepts. We have design courses, as well as an opportunity for students to engage in learning using computer-aided design and computer-aided manufacturing processes and software. There's courses on matter and energy, electricity, magnetism, and waves. And all of this is very important to build a foundation for subsequent study. After a common first-year program, you would choose computer engineering, and that would then take you into a stream of courses that are going to consist of some computer science courses. So for instance, in your second year, Computer Science 222 is a data structures course. Then there would be courses in electrical engineering. And for example, in the second year, you would study one would be on signals and communication systems. That's Applied Science 270. And a course on digital logic design is another example. And then we have a third set of courses that are focused on computer engineering and that bridge between electrical engineering and computer science. And we have a first course in computer engineering called Computer Engineering for Science and Technology, and a design studio course in the second term that allows you to get a first opportunity to apply and get design experience in the computer engineering field. In the third year, it's a similar type of course concept where we have courses in computer science like software engineering, courses in electrical engineering. 359 focused on microcomputer engineering. So that's looking at the hardware architecture, microelectronics. And then there's a computer engineering course called Software Systems and Design for Engineering. Again, another opportunity to apply both electrical engineering and computer science concepts to computer engineering field. In the fourth year, this is principally an opportunity to specialize, and it's primarily consisting of electives in computer engineering or electrical engineering or computer science. But we have some mandatory courses, and the first one is on quantum computing. And there's a course on law and ethics, which is in alignment with training to become a professional engineer. And then the electives are related to computer networks, computer architecture, cybersecurity, artificial intelligence, intelligent robots, and Internet of Things. Those are just some examples of courses that you would have an opportunity to specialize in your fourth year. While studying at UBC on the Okanagan campus, there are a number of other opportunities just outside the scope of courses that are provide many, many experiential learning opportunities. And some examples are the co-op program, where you get an opportunity to work with industry. There are opportunities to study at other universities around the world. And we got programs called Go Global that allow you to participate in that. You could join a mentorship program and work with other students in the program. There are many, many clubs that are available to students that provide social, professional, and technical opportunities. And finally, we have opportunities to engage in undergrad research with the faculty in computer engineering, electrical engineering, and computer science. So what kind of students take computer engineering? Dahlia is one of our second-year computer engineering students, and on the slide right here, you see some of her comments. I just want to read the first paragraph here. My passion for programming played a significant role in my decision to pursue computer engineering. I wanted to choose a path that I would genuinely enjoy, rather than settling for something that might leave me unfulfilled. And as a faculty member and having worked with many, many students, I can very much connect with the genuine interest in a field. And I see that students really excel when they find the area they're connecting with the knowledge and are interested in the roadmap that knowledge is leading to. So Dahlia's again giving a really excellent example in her own words about that the passion for the field. So why study computer engineering at UBCO Okanagan? The first point I'd like to emphasize is the training that you will receive from both two faculties. The first being the engineering faculty in the School of Engineering and the computer engineering faculty, and then the computer science faculty. So you have both that science and engineering background. And I think getting that experience from two different faculties is very, very valuable as you are going through your education. We also have a strong emphasis on design right from year one, and every year there are design-related courses, and we are trying to provide training that gives you an early opportunity to enter into the co-op stream, and so having that design experience is very important. We also offer, I think, a unique opportunity in terms of quantum computing area. That's a mandatory course. That is something that is unique to our program. And we also have a wide range of electives that allow you to specialize in areas like cybersecurity, computer networks, intelligent robotics, AI and high-performance computing architectures. After your first year, other aspects about our program are after your first year, if you're interested in computer engineering and you have a grade of 60% or higher in our first year programming course, you're guaranteed a placement in our program. And so you would get to enter the computer engineering stream. The School of Engineering has a culture that encourages undergrad research opportunities. So faculty are very much interested in working with undergrad students on research projects. And the last point is, I think computer engineering is really an excellent field to get into as technology evolves, and it will continue to be an instrumental part of developing solutions for solving new problems and applications. With that, I hope this is giving you an overview of our program, and I look forward to seeing you on our campus.